Hi everyone, here we've got another problem where we are going to apply Newton's second law to find, in this case, the acceleration and the force of tension. I've got a block A up here. There's a string attached to block B. If I let go, we assume my system is going to accelerate, thusly block A to the right, block B down. Let's say that we were told mass of A and mass of B. I'm just going to do this one symbolically. I want to find the acceleration and the force of tension. We should be noticing a pattern in these problems. We start with a free body diagram. For block A, the only thing pushing it to the side, if we assume it's frictionless, we haven't involved friction yet in our problems, I'm going to have that force of tension pulling off to the side. Pardon me with that focus. The force of tension pulling off to the side. That means that my free body diagram, translating into Newton's second law, is just going to say that my force of tension is going to equal the mass of block A multiplied by my acceleration in the x direction, where I've obviously said that this direction is positive x. Now for block B, what I'm going to do is make a new choice of coordinate system. I'm going to say that down is positive x. And the reason I'm doing that is I know that this is going to accelerate in that direction. So I'm going to have an acceleration of this block, which should be the same as block A since they're connected by a string. So my free body diagram for this one, I'd say that I've got the gravitational force for block B down. Here I've got the tension force up. And I know that I should have drawn my, here I'll just make it annoyingly big. That vector should be bigger because I will be accelerating down in the positive x direction. So here I'm going to actually say that this is the sum of forces in the x direction for block B. I'm going to have Fg of B minus that tension force, and that's going to be the mass of block B times my acceleration in the x direction. Now the reason, again, I made this choice is now that's got to be the same acceleration that I had for my first equation. So if I look at my two equations that I came up with in the previous 2 pages, I've got the force of tension in both equations. I've got the acceleration in both equations. I have 2 equations, 2 unknowns. That means I can substitute one back in the other. I can make, for this problem, a direct substitution of the force of tension in for this force of tension in this equation. I'm also going to write the gravitational force on block B as the mass times the gravity. That's the weight of block B. So the gravitational force is mb times g minus, now that substitution, ma times ax equals mb times ax. So that means that mb times g is going to equal the mass of block A plus the mass of block B times ax. So my acceleration in the x direction is simply going to be the mass of block B times g over my total mass ma plus mb. Then I can substitute this back in for the tension to say that then my tension force, which we said was ma times, yes, we did. We said that was ma times the acceleration in the x direction. Well, we just solved for the acceleration in the x direction. So all I'm going to have there is now ma times mb times g over my total mass ma plus mb. So that's going to be my tension force. Again, the secret to this problem, not secret, I just told you what it was. It's not a secret. The key to this problem is that we have a downward positive x direction. We are free to choose x in whatever way we say we want it to be. I'm choosing it this way so that it matches the acceleration of my other block, right? So now I have acceleration in the x direction in that equation, and I have acceleration in the x direction in that equation, and it's the same exact thing, and that allows me to make that substitution in the next page in order to solve for my acceleration itself in terms of the masses and the gravitational acceleration.